In this video, we will be learning how to solve conic systems. Specifically, we're going to be finding the intersection of a line and a circle. Alright, so we're supposed to solve this system. Can you tell that this bottom one is a line and the top one is a circle? Okay, bottom one does nothing squared, so you know that's a line. Both things are squared, so you know that's going to be a circle. So this one has the first step sort of already done for us, because notice how there are no parentheses. That means we're already ready to do the substitution. Sometimes we're given the circle that's in standard form. Let's see if I can find an example. Yeah, if you're given the circle in this form, you have to multiply it out first. You have to go like x minus 4 times x minus 4 and y minus 2 times y minus 2 and multiply all that out. Would you know how to do that if you needed to? Okay, so on this problem we're skipping this step that's already basically been done ahead of time. Okay, so picking up from there, so I'm going to do substitution. For substitution, the first step is to get one variable by itself. So you're always going to use the line to do that because it's simpler. So in fact, looking at this line, see the x and the y? Which one of those two variables is closer to being by itself? The x, because it has no number in front. So I would target the x and get the x by itself. So I would do that by adding 2y to both sides. So we have plus 2y plus 2y. So that's going to give us x equals 2y plus 1. All right? So once you have one variable by itself, and it could have easily been y, sometimes it'll be x, but you take that expression and you substitute that back into the problem for that variable. So this is x equals, so I'm going to take this and put it everywhere I see an x. So I see two x's, so I'm going to plug it in those two places. Let's see. So this was x squared, so that means down here I'm going to have, what is this, 2y plus 1. So I'm going to have 2y plus 1 squared. All right, and then we have y squared, so I'll just bring that down. Okay, and then we had minus 2x. So that'll be minus 2, but instead of x, again, I'm going to put another 2y plus 1 in that spot. Okay, and then I have the rest of it. 10y minus 14 equals 0. So plus 10y minus 14 equals 0. Notice that on this step we don't have any x's, all y's. So as soon as you see that, we should be able to solve this for y since it's only one variable. So like I sort of alluded to before, when you have a binomial squared, like we have right here, you have to write it out side by side. So you have to do 2y plus 1 times 2y plus 1. And then I've got my y squared. All right, right here I'm going to go ahead and do the distributive property with this negative 2. So that's going to make negative 4y minus 2 right there. Okay, then I'm going to bring down my 10y minus 14 equal 0. Does that make sense so far? Okay, so then with the binomial times the binomial, I have to do the distributive property twice. So first I'm going to distribute that 2y. So 2y times 2y is going to give me 4y squared. And 2y times 1 is just going to give me 2y. And then I'm going to distribute the 1. So 1 times 2y is 2y. And 1 times 1 is 1. Okay? So bringing down other things. Okay, so here I have y squared I guess I'll just bring it all down. Y squared minus 4y minus 2 plus 10y minus 14 equals 0. So now it's time to combine all my like terms now that all the parentheses are gone. So I'll start with the y squared terms. So here I've got 4y squared and just 1y squared. So that's going to make 5y squared. Okay, and then I'm going to do the y terms. Okay, everything I just highlighted in yellow are y terms. But at a glance, I can see that first pair, that's positive 4y. But then next thing I see is a negative 4y. So these two are going to cancel each other out. So that's just going to leave the positive 10y. So I'll bring that down. Okay, and now I've got the constants. Okay, and the constants are just the 1, the negative 2, almost skipped it, and the negative 14. So 1 and negative 2 make negative 1 and negative 14 make negative 15. So I just have minus 15 equals 0. Notice that all three of these happen to be divisible by the same thing. So this step is optional, but why not make your life easier by dividing everything by 5?
You do it.
Okay, so that's going to leave y squared plus 2y minus 3 equals 0. Now, whenever this looks ugly, like big numbers, I just use the quadratic formula. But if it's really small numbers, it's usually easier to factor if you know anything about factoring. So y squared, as I factor it, it's just going to be y times y. And I'm looking at that 3. There's only one way to do 3. It's going to be 3 times 1. The inner plus the outer have to equal the middle. So in my mind, I'm thinking inner 3y, outer 1y. I need to get a positive 2y out of that. I can get that if I have a positive 3 and a negative 1. So that's why I'm going to do positive 3 and a negative 1. Then I glance back to make sure I'm really going to get a negative 3 when I multiply. And sure, because positive 3 times negative 1 does equal negative 3, so that works as well. So we've now factored it correctly. Do you know what the next step would be for this? Okay, when you're factoring and you're trying to solve, you take these two factors and you set them each equal to 0 to get your two separate solutions. Okay, so I can do y plus 3 equals 0, that will give me one solution, and y minus 1 equals 0 will give me a second solution. Okay, so here I would subtract 3 on both sides. Here I'm adding 1 to both sides. So this is going to give me y equals negative 3. And this is going to give me y equals 1. Okay, so we're not completely through. We have these two y values, but we need the x values that go with them. So what I like to do is make a t-chart, a table of values. Okay, so let's see how do I want to. Okay, so I'm going to make a small chart of x's and y's. Okay, like this. So we have these two y values right here. So we have a y value of negative 3, and we have a y value of 1. So if I want to find the x values that go with these y values, I'm going to go all the way back to the little equation they gave me. Well, I modified it slightly, but I'll use the version that says x equals 2y plus 1. Okay, so I'm just going to write that down right here. X equals 2y plus 1. So using this formula, if y is negative 3, then that means I have 2 times negative 3 plus 1 should give me the x value. So that's going to be negative 6 plus 1, so that'll be negative 5. If the y value is 1, then this little equation gives me 2 times 1 plus 1. So that's just 2 plus 1, so that would be 3. Okay, so this should be, these should be the two solutions. And you could write it as an ordered pair. So negative 5 comma negative 3 and 3 comma 1. Okay, that's one way that you could have solved it. There's another way that I'll be happy to go through if you want me to. This is sort of the way I had taught it in class, the way I just showed you just now. But I could have completed the square, converted this to standard form equation of a circle, and then graphed them both. That's why this graph paper is sitting here. And then I could have seen where they met. The reason why I didn't do it that way in the first place is because sometimes they meet at decimals. You know, so it might be negative 3 over 5 or 2.71 or something like that. If I graph it and then see that they don't meet evenly, then I don't know. Then I have to do it again. So, but if I do it algebraically, then I have the answer no matter what. Okay? All right, let's do one more problem. I'm solving a system of conic sections. We're going to find the intersection of this line and this circle. And I'm just going to do it algebraically. So what you do is, this y value is already by itself. So that means I can take this 2x minus 10 and substitute it in for y right there. So if I do that, got a lot of space up here. That's going to give me, all right, so if I do that, then, all right, I'm just going to put it up here. So that gives me x squared plus, now here comes y squared. But instead of y squared, I'm going to put 2x minus 10 squared. And that's equal to 13. So that's going to give me x squared plus, and I'll have to write 2x minus 10 times 2x minus 10. So I'm going to have to double distribute this. So I'll distribute the 2x, so that's going to give me 4x squared. And then 2x times negative 10 is negative 20x. And then I'll distribute the negative 10, so that's going to give me negative 20x plus 100. Because negative 10 times negative 10 is positive 100. So I'll bring down the x squared. Okay. So I'm going to combine my like terms. So this is going to give me 5x squared. Okay. Putting these together, that's negative 40x. And then if I subtract 13 from both sides, okay, that's going to be 87 is equal to 0. All right, so I'm going to use the quadratic formula to solve this. Remember that the quadratic formula looks like this. All right, given a quadratic equation, x is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So this part of the quadratic formula is called the discriminant. And I always recommend calculating the discriminant first, because if that turns out to be a negative number, you can just stop. So this part, the b squared minus 4ac, that's under the radical when you're doing the quadratic formula, that's called the discriminant. So that's what I mean when I talk about the discriminant. And because it's under a radical, then we have these situations right here. The normal thing that happens, the most common thing is you get a positive number under the radical. All right, and because of the plus or minus in the quadratic formula, you usually wind up with two solutions. Okay? On the other hand, if the discriminant is 0, and then that winds up under the radical, but plus or minus 0 isn't really a new number. Adding 0, subtracting 0 doesn't change anything. So that's why when you have 0 discriminant under the radical, you really only wind up with one solution. On the other hand, if the discriminant is negative, then that means you have a negative number underneath the radical. All right? And you know that gives you imaginary numbers. So that's not really a solution at all. Now, just in terms of parabolas, look at these little pictures right here. If we were talking about x-intercepts, we'd be saying, oh, look, when it has two solutions, that's two x-intercepts. If it has one solution, that's one x-intercept. Okay? The imaginary one meant that there were no x-intercepts. But of course now, if I can get back to what we were talking about a second ago, if you look at it in these terms, where if you're solving a system of a line and a circle and you use the quadratic formula, if the discriminant is 0, how many solutions did I just say there were if the discriminant is 0? That's one solution. That means if I say how many places does the line intersect the circle, it means it must be one of those situations where the line only hits the circle once. So it must be like this, like here you have a circle, and then here you have a line. Okay, and it must be one of those where the line only hits the circle one time. Okay, so similarly, just real quick, let me zoom out a little bit. Okay, so what do you think? If you're solving a conic system and you have to use the quadratic formula and you get a positive, how many places does the line intersect the circle now? That's your two. Your two solutions in this context means two intersections. Okay, so it must be your typical case where we have a circle with a line going through it. It could hit twice. Okay, but what happens if the discriminant is negative? Right, that means you're going to get imaginary. That means it must be one of those situations where the line and the circle simply do not meet at all. Okay, so be prepared to answer questions like that, like questions in words, like this warm-up. Okay, as well as if you're actually doing a problem like number 15 here, understanding that if you do get a negative number for the discriminant, you're going to stop immediately and say no solution. Okay, so having said that, let's finish number 15. Okay, so we have A, B, and C. So I'm just going to substitute those into the formula. Oh, what did you do, my brother? So it says opposite of B. So opposite of negative 40 is positive 40. Plus or minus square root. Okay, I'm not sure if I left myself enough room. B squared. So that's got to be 40, or negative 40 squared. Make sure you put it in parentheses. Minus 4 AC. So that's minus 4 times 5 times 87. All over 2A. A is 5, so 2A is 10. Now again, I would do the discriminant now. I wouldn't put this entire thing into the calculator if I were you. I'm just going to do the negative 40 squared part. Ready? All right? You might need to help me remember it. Just make sure you put the negative 40 in parentheses for sure, or else you will get the wrong answer. So I got negative 40 squared minus 4 times 5 times 87. So minus 4 times 5 times 87. Oh, wow. Wow. What does that tell you?
There's going to be imaginary numbers.
It's going to be imaginary numbers, so what do I do now?
You got 40.
Say it louder. Somebody was saying what to do. No solution. Remember what we just talked about? It means the line and the circle don't intersect. So there will be no solution. So we just stop. As soon as we see that the discriminant is a negative number, what was it, negative 140? Okay, so x is equal to 40 plus or minus. Okay, we stop immediately and we say, oh wow, look at that, no solution. That's a good question. I'm not gonna use the graph at all. The graph is there. It could help you.
On the test, if it's there, you don't have to use it.
You don't have to use it unless it's specifically said. You don't have to use it.
So on the test, if we get to
Okay, so here endeth the lesson. You want to say something? Antonio.